In today's video, we will be focused on to quadratic factorization, or you can call it trinomial factorization. So what we're essentially trying to do is, let's say we have something like x squared plus 3x plus 2, and we want to factor them into x plus 1 times x plus 2. You have two separate terms, and each term has an x and a constant. And how do we do that? First, you have to know how to factorize normal expressions like this, or something like x squared plus 3x. So in both cases, you are finding a similar term. So you want to find a common factor. So in this case, 3 would be the common factor. You take it out. So you divide by 3, you have x left. Same with the 6, divide by 3, you have 2 left. And on the other side, you have x squared plus 3x. So you just notice x's on both sides. So you take out an x. So you have 1x left. And you have a 3 here. So that's how you factor normal expressions that are not quadratic. And let's take a look at the second example. So we have x squared plus 3x. Let's assume x is not just x, it has different meaning. It equals to y plus 1. Now in this case, we can substitute this into x. So we have y plus 1 squared plus 3 times y plus 1. Now you notice that since we see both terms that have y plus 1 here, what we can do is we can take out the y plus 1 in front, and let's have a big bracket here. And since this is a square, I take 1 out, I have another copy here. And 3 times y plus 1, I'm taking out the y plus 1, so I have 3 here. So now I can simplify the second term here to get y plus 1 times y plus 4. Now notice that all I have done was changing x into y plus 1, and the factoring is essentially the same. Now what we're going to do here, we're going to explain how that works in a different scenario. So we have a plus a times b plus c. Now we can write this as 2a times b plus c. Distributive law tells us that we can multiply 2a by b and 2a by c. So you have 2ab plus 2ac. Now another way of we can do this is we can rewrite this as ab plus ab plus ac plus ac. I'm just simply breaking up the two ab's and two ac's. And look what I'm doing. I'm going to swap these two. I'm going to have ab plus ac plus ab plus ac. The common term is I have a here. I can factor out the a, and I have b plus c. And I can factor out the a here again, and I have b plus c. Notice that the b and c are the common terms. I can now take out the b plus c in front, and now all I have left here is an a here, and the second term I also have an a here, which equals to what I have at the beginning. This is this. Alright, so if I have two terms where, let's say they are all unique, a plus d times b plus c, the previous distribution law tells us that we have a term here, we have to multiply by b and c. But since this term has two other terms inside, so you have something called a rainbow distribution. How that works is you have to take the for term and multiply by the first term of the first small term of the second term. Then you have a times c, then you have d times b, and d times c. So from out to in. Something called FOIL, meaning first outside, inside last. Something that is easy to remember. So now we have got this out of the way. Let's look at this example. X plus 3 times x plus 2. So using that distribution law, you're actually multiplying x by x plus 2 and 3 by x plus 2. We're just reversing the procedure here. Now we're going to expand this. I have x squared plus 2x, and here I have 3x plus 6. Now I can combine the x's. I have x squared plus 5x plus 6. So that would be the same if I did this. If I did the FOIL. So x times x, I have x squared. X times 2 is 2x. 3 times x is 3x. And 3 times 2 is 6. So that is this second last step here, which gets us x squared plus 5x plus 6. So that's how you distribute two separate terms that have two other terms inside that are unique. So these are what you're going to be seeing in quadratic factorization, because they'll all be in this form, and you would want to factor them into two different factors. Okay, let's look at the first case. Now the first rule is something called difference of squares, and it's literally what it says, difference of squares. You're just subtracting the two squares, and you get something like x plus 8 times x minus 8, and I'll tell you why. When I multiply them, x times x is x squared, and then the last term will be 8 times negative 8, which is negative 64. Now in between, I have x times negative 8, which is negative 8x, and the middle multiplication will be plus 8x. And you notice these are cancelled to 0, so all you have left is x squared minus 64. So you always know that if we have... Now the second rule is called perfect squares factorization. So we have x squared plus 6x plus 9. In this form, if you look at the constant, 2 times of the square root of the last digit here is always equal to the constant here. So if you do it, we have 2 times square root of 9, which is 3, and that's equal to 6. So any case you have such a form, you can also write it as x plus 3 squared, because it's a perfect square. The third is called 4-term expressions, or you see actually 4 terms here. And previously we've kind of gotten over this. Essentially is you have 4 terms here, and the x term is split into 2 separate terms. And by doing that, you notice we have a common factor here and a common factor here. So 2x is a common factor. I can factor that out. I have x left. Dividing negative 4x by 2x, we have minus 2. And we have 3 as the common factor. So I have 3 here. And with x left, negative 6 divided by 3, I have negative 2 left. So we have x minus 2 as the common factor. We can factor that out, and we get x minus 2. And whatever is left inside, we have 2x, and we have positive 3. So we have 2x plus 3. And that is how you factor 4 separate terms. Fourth is something called a common multiple. This is actually the easiest one, because you will see why in a second. So 2x squared minus 6x minus 8. You notice we have a common factor in each of the numbers here. So we can take that out. All we have left is x squared minus 3x minus 4. We're looking to see whether we can factor that further, and we notice we could. So let's factor this out. So we have factors of 1 and 4, 2 and 2. Now we have to figure out which ones give us a difference of 3. So the first one gives us a difference of 3. So I'll write down 1 and 4 here. And since this is a negative 4, that means one of these signs is a positive and the other must be a negative. Otherwise you cannot get a negative. And so it has to be either positive, negative, or negative, positive. And how we're going to find out which one is positive, which one is negative. So we notice if we multiply x by 4, we have 4x. 1 by x is x. We need, if 4x was positive, then x would be negative. So we have 4x minus x, and that is 3x. But we want a negative, so it must be this 4x is negative, the x is positive, so we have negative 4x plus x, and we get negative 3x. So in that case, the 4 is negative and 1 is positive. I'll go over this again when we actually go into the quadratic forms, because there are different signs. But for a simpler one, I'm just going to go quickly and just trying to show you the factoring of a common factor here. So now we're going to go through the actual quadratic expressions. So we have 4 different scenarios with different signs. The first one, they're all positive. So we have x squared plus 3x plus 2. Both are positive. The second one, we have x squared minus 6x plus 5. Third, we have x squared plus 7x minus 8. Fourth, we have x squared minus 5x minus 4. So the second sign is negative, and the third is positive. And the third, we have positive, negative, and finally we have minus, minus. So we would go over each of them one by one. First, we have x squared plus 3x plus 2. And how we're going to do it, we're going to form 2 big brackets, or pairs of brackets. The first term of each bigger term, they come from the first term of the trinomial. So you have x squared, that means each of them must be an x. Unless we have a number that is not a 1 here. So this is a 3, then we have to look at all the factors. So we'll do that later. Now, second, we have to look at the last term of the trinomial, because the second term of each bigger term here, they come from the factors of the last term of the trinomial. And the factors are 1 and 2. So 1 and 2 must go in either spot. So let's just put them down. It doesn't matter because the x coefficient, they're 1. So it doesn't matter where I put them, how I put them, it's not going to matter. What matters is the sign. But since both are positive, because we have a product 1 times 2, right? So in order to get a positive at the end here, it must be both positive to get a positive product, or both negative to also get a positive product. And that is how you do it. Now for the second one, we have x squared plus 6x plus 5. So let's form the 2 brackets again and write down the x's. Now the factors of 5 is 1 and 5, so you have 1 here and 5 here. Now since the 5 is positive, so again we have either both positive or both negative. Since we have a negative 6x here, they must be both negative. So negative and negative. And you can check. Negative x here, negative 5x here, and together we have negative 6x. Number 3, we have x squared plus 7x minus 8. Again, 2 pairs of brackets. We have a negative here, so it must be 1 positive, 1 negative, or 1 negative, 1 positive. Let's put in the x's. Now, this is a little harder because I have 1 and 8 and 2 and 4. Since the signs are alternating, that means we're going to be finding the differences of these factors. The differences is 2 here and 7 here. So 1 and 8 will fit in. Now we have to look at the sign. Since we have a positive 7x, we have 8x here and x here. So the bigger one has to be positive and the smaller one to be negative. So the one next to the 8 is positive, next to the 1 is negative, and we're done. Number 4, we have x squared minus 3x minus 4. Let's write down the 2 brackets with x here and x there. Now let's look at the factors of 4. 1 and 4 and 2 and 2. So we have a negative 4 here, meaning the signs are alternating. We have one positive, one negative, or one positive, one negative in order to get negative at the end. So we're looking at differences. The difference between here is 0. The difference between 1 and 4 is 3. So it must be 1 and 4. Now look at which one's going to be positive, which is negative. So this is 4x. That's the x. We want negative 3. So this has to be negative, because if we have negative 4x, this one is positive. So I have negative 4x plus x, which is negative 3x. So 4 is negative and 1 is positive, and we're done. So those are the 4 different variations you will see. The next one we're going to talk about is where there is a coefficient that is not a 1. So we'll see an actual number there. So what does it look like? Now I'm going to show you an easier one and a more difficult one. So the easier one is 3x squared plus 11x minus 4. Again, let's write down the brackets. Now what we do is we're going to show all the factors of the x squared coefficient and the constant here. So constant is 4 or negative 4, but it doesn't matter the sign because we're just looking at the positive right now. 1 and 4, 2 and 2. So since there's only one pair, we're going to just write down 3x here and x here. It's a conventional thing to write down the bigger one in front, but it doesn't matter. They're both correct. So what should we do? So one of these numbers will be multiplied by one of these numbers as well, and the other with the other. So let's say I have 3 multiplied by 2 and 1 multiplied by 2. So if I say the product of 3 and 2 is 6 and the product of 1 and 2 is 2, there's no way I can get an 11x. So that means 2 and 2 will not work. So it has to be 1 and 4. If I did 1 and 3, I get a product of 3. 1 and 4, I get a product of 4. Again, 3 and 4, there's no way I can get the sum or difference to be 11. Now, but if I do it the other way, 3 and 4 gives us 12. 1 and 1 gives us a 1. So we can form 11 based off of 12 and 1 to make 11. Now, if the 4 is connected to the 3, so the 3 is connected to this number, so the 4 must be here. The x here is connected to the 1, so the x must be connected to the 1 here. So once we have the numbers in its right spot, we have to think about the sign. We know it has to be a positive and negative, or negative positive alternating sign. We want a positive 11, so that means we want 12x to be positive and we want x to be negative in order for the difference to be 11x. So 4 is positive, 1 is negative, and we're done. This is the easy one. Let's look at the harder one. The harder one is 6x squared minus 5x minus 14. Notice 6 has 1 and 6, 2 and 3. 14 has 1 and 14, 2 and 7. So writing down the brackets here, we have to figure out which numbers go here. So let's put down the x first. This is a little tricky because you have multiple scenarios. I could go 6 here, 1 here, and I could take any pair. So I could do 1 here, 14 here, or 14 here, 1 here, 2 here, 7 here, or 7 or 2. So I have at least 4 different ways of doing it when working with the first pair on the left hand side. But I have also 2 and 3. So that means I have 8 ways of finding the answer. So the probability of you guessing it right would be 1 over 8, which is 12.5%, which is very low. So let's find out the products in which we can get 5 here, or negative 5. So let's look. Since if we are multiplying 6 and 14 like this, the numbers will be huge, right? It will be 84. and then the product of 1 and 1 would be just 1. There's no way to get 5 from there. Now, if we do it the other way, 6 and 1 is 6, 1 and 14 is 14, which is, the difference is 8. So there's no way we could do a 5 here. So this doesn't seem like a plausible solution. And 1 and 14 does not work well with 2 and 3 either, because they are so close together. The 14 and the 1 are too far apart, so it will make the number very large anyway. So that's not a good solution. Now, shall we look at 2 and 3 and 2 and 7? Well, 3 and 2 will give us 6. 2 and 7 will give us 14. 14 and 6, the difference is 8. That doesn't work. What about this, the other way? 21 and 4, that means this is no good. So we have 1 and 6 and 2 and 7. So let's think about it. That's 12, that's 7, so we have a pair. Like that. I could have done 6 and 7 and 2 and 1, but I was just lucky, right? And over time, you will have a better idea of which pairs to try first. Since these two are too small, these are much bigger, there's no way to get a small number. So 6, let's put 6 here and 1 here. So 6 will go with 2, and the 1 will go with the 7. Now we just have to figure out the sign. We know it's from the negative 14, it must be positive negative or negative positive. Let's write down the products here. So we have 7x here, and we have a 12x here. And we want a negative number, so that means the big one has to be negative, and the positive is the smaller one. So 7 is positive, and the 2 is negative, and we have our answer. Many teachers and textbooks provide this method to solving 6x squared minus 5x minus 14, because there's not much guessing going on. The way we do this is we take the coefficient of x squared and we take the constant, then we multiply them to get 84. Now what we're going to do is we have to find all pairs of factors. So 1, we start with 1 all the time. 1 and 84, 2 and 42, 3 and 28, 4 and 21. And no 5, so 6 and 14, 7 and 12, and 8, there's no 8, 9, no 9, 10, no 10, and no 11. So that will be it. So now we look at each pair, and we want to find a difference of 5. So none of these work except for 7 and 12, which you already know. So we're going to split the middle term by writing the following: 6x squared, and we're going to write plus 7x minus 12x minus 14. So we have to be careful about the sign of each one, because we want a negative, so the 12 must be negative. Now we're trying to form a factorable pair. So 6 and 7 don't go well together, but 6 and 12 go well together. So I'm just going to swap these two and get 6x squared minus 12x plus 7x minus 14. So the common factors here are 6x, and what I have left is x minus 2. The other one, I have a common factor of 7, and I have x minus 2 as the residual. Notice x minus 2 is a common factor. I can take that out. What I have left in the first term, I have 6x here, and I have positive 7. And there you go. You have the answer. This one takes quite a long time if you have to figure out all the factors of the first coefficient and the last constant. It's something I don't recommend personally, because through practice, my method is far superior than this method, because you have to take your time, multiply them. And what if you multiply them incorrectly? Although you're allowed calculators, but we don't want to rely on calculators. So this is basically the introduction of quadratic factorization or trinomial factorization. Hope you enjoyed it. Hope you've learned something. And if you have any questions, feel free to comment on this or drop us an email at mathematics@gmail.com. Link will be in the description. And if you enjoyed this, please subscribe our channel. I would greatly appreciate it. And give a thumbs up so that more people can know about my approach to mathematics. And then hopefully I'll see you around next time.